Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 5.2, which is going to deal with using intercepts. Now, for today's lesson, we have two learning goals today. Our first learning goal is that you will be able to identify and use the X and Y intercepts in a linear relationship, and you will be able to interpret the meaning of the X and Y intercepts in a given situation. So today we're going to take a look at how to identify your X and Y intercepts based off of an equation or a graph, and then also be able to go through and interpret the meaning of those X and Y intercepts. Now let's talk about what an X and Y intercept is first before we get into our examples today. Alright, the Y-intercept of a graph is the Y coordinate of the point where the graph intersects the y-axis. So y-intercept is where it crosses the y-axis. The x-coordinate of that point is always 0. Now the x-intercept of a graph is the x-coordinate of the point where the graph crosses the x-axis. So y-intercept is where it crosses the y-axis. The x-intercept is where it crosses the x-axis. And the y-coordinate at that point is 0. So when we talk about the y-intercept, we're talking about where it crosses the y-axis and what the y value is, and the x value is going to be 0. Now the x-intercept is where it crosses the x-axis and the value of x, and y is going to be 0. So if we're talking x and y intercept, so if I go through and pull up a little graph, the y-intercept is where it crosses the y-axis. So this is my y-intercept. And then my x-intercept is where it crosses the x-axis. So y-intercept is where it crosses the y-axis. X-intercept is where it crosses the x-axis. Now, for just basic purpose of this, I could say my y-intercept in this case is 2. And my x-intercept in this case would be 1.5. Because my graph crosses the y-axis at 1, 2, and my x-intercept crosses at 1.5. So y-intercept crosses the y-axis, x-intercept crosses the x-axis. So we're going to keep that in mind for today when we go through and do these problems. All right, so with that said, example 1 is going to ask us to go through and find the X and Y intercepts. So we need to go through and determine where these equations cross the X and Y axis for each problem. Now, there's a couple ways you can do this. The first way is you can plug zeros in. So the first way would be that I would take 0 and plug it in for x, and then I would take 0 and plug it in for y. So I'm going to go through and do that for the first one. Then I'm going to show you a shortcut for parts B, C, D, E, and F. All right, first one. So we're going to plug 0 in for x. So we have 3 times 0 minus 2y equals 6. And then you would go through and plug 0 in for y. So we have 3x minus 2 times 0 equals 6. So we're going to go through and figure out what x and y equal for the respective side. And that's going to tell us our x and y intercepts. Now, anything times 0 cancels out. So I now have negative 2y equals 6. Negative 2 times 0 cancels out. So I now have 3x equals 6. So that allows me to then go through and solve for x and y. If I divide by negative 2, 6 divide by negative 2, and let's pull out my calculator. We do 6 divide by negative 2. We end up with negative 3, so we get y equals negative 3. And if I go through over here and I divide by 3, if I do 6 divide by 3, I get 2 as my answer for x. So that means my x-intercept is at 2 and my y-intercept is at -3. And that is one way to go through and find your x and y-intercepts, where you can go through and plug 0 in for x and then 0 in for y to figure out what y equals and then what x equals for your x and y-intercepts. Now, that is all well and good, but there is a way that we can remove one of these steps, and that's by plugging in 0. So we can kind of take that step out. This is a little bit of the shortcut, but just know if you feel comfortable with this by plugging in 0 for x and then plugging 0 in for y to get y and x, then you're all good to go. So my y-intercept is -3 and my x-intercept is at 2. So that is all that I would have to do for part A, and that's our answer for example 1A. Now parts B, C, D, E, and F are going through and doing the same thing. It's just a different equation. Now I do want to talk about a shortcut for us today, and that shortcut is going to be what I refer to as the cover-up method to go through and do this. So if I want to go through and find my x-intercept, what I'm going to do is cover up my y's. So I have -5x plus 6y equals 60. If I want to figure out what my x-intercept is, I'm just going to cover up y. So if I cover up y, I now have a -5x. Whoops. See if I can get this to cover up just right. All right. So I have a -5x equals 60. So my cover-up method has me eliminate the y, so I just have a -5x equals 60. I then just have to go through and solve for x. And to do that, we're just going to divide. So we're going to take the 60 and divide it by -5. So if I do 60 divided by -5, I end up with x equaling -12. And that is my x-intercept. Now to solve for your y-intercept, we're going to go through and cover up the x values. So I now have a 6y equals 60. So to solve for my y-intercept, we're just going to divide by the number in front of y. So we're going to do 60 divided by 6. And I end up with my y-intercept being 10. So my x-intercept is at -12. My y-intercept is at 10. So it's very similar to what I did in part A. It's just the difference is I didn't plug in 0. I just went ahead and eliminated the x and y for each respective part to go through and find the x and y intercept. So if you prefer to plug zeros in, by all means go through and plug zeros in and then solve for x and y. So plug it in for x, plug it in for y, or you can use the cover-up method to solve. So that's really what the rest of example 1 is just finding x and y intercepts. And I do want to just practice a few more just to give you a little more practice with it. All right, for C, from here on, I'm going to use the cover-up method. If you want to plug 0 in for x and y and solve, go ahead and do that, and then see if you match up with what I get. You should, if you do your math correctly, get the same result. Now, if I look at C, for C, I have 8x plus 7y equals 28, and I need to go through and find my x and y intercepts for this problem. So for my x-intercept, again, I'm going to cover up my y value. So I now have 8x equals 28. So if I have 8x equals 28, what I'm going to do is divide the 8 to the 28, to figure out what my x-intercept is. So we're going to go through and do 28 divided by 8, and I get x to be 3.5. So that is my x-intercept. Now to figure out my y-intercept, remember, so I went through and covered up my y to figure out my x. To figure out my x-intercept, we're going to go through and cover up the x values. So for my y-intercept, I have 7y equals 28. To solve for my y-intercept, we're going to do 28 divided by 7. So if I do 28 divided by 7, I get my y value to be 4. So that means my y-intercept is going to be 4. And that is my x and y intercepts for part C. Now, if it wanted you to give your x and y intercepts in coordinate point form, your x-intercept would be 3.5, 0, and your y-intercept would be 0, 4. So if it wanted you to go through and actually write the coordinate point for your x and y-intercept, x-intercept you have a 0 for y, y-intercept you have a 0 for x. Alright, so let's continue on with our practice for both of these. So for D, we have a negative 6x minus 8y equals 24. Again, I'm going to go through and use the cover-up method to solve. So if I want to solve for my x-intercept, we're going to go through and cover up my y. So we're going to cover up the negative, or the minus 8y. So I have a negative 6x equals 24. So negative 6x equals 24. To solve for x, we're going to divide by negative 6. So we're going to do 24 divided by negative 6. And I end up with negative 4. So that means my x-intercept is going to be negative 4. And then to figure out my y-intercept, we're going to cover up x. So I now have a negative 8y equals 24. So we're going to take this negative 8 and divide it to 24. So we're going to do 24 divided by negative 8. And when I do 24 divided by negative 8, I end up, in this case, with my y-intercept being negative 3. So my x-intercept is negative 4. My y-intercept is going to be 3. So if I went through and wrote these out in coordinate form, it would be negative 4, 0, and then 0, negative 3. And that is how you go through and find your x and y intercepts for part D. Alright, so E and F are continuing with the same idea. The difference for E and F is that there are fractions. Now, even though there are fractions, you just treat this the same. So I do want to talk about at least one of these. So I am going to look at E. I will leave F for you to go through and do some practice on your own if you need. But let's go ahead and take a look at E first. Alright, for E we have 2/5 x plus 1/2 y equals 20. So again, I'm going to go through and use the cover-up method. So to figure out my x-intercept, I'm going to cover up my y. So I have 2/5 x equals 20. Now again, what I have done so far with this is I've taken the number in front of x and divided it to the number on the other side. So that means I need to do 20 divided by 2/5. So we're going to do 20 divide. Now, anytime you are dealing with a fraction, please use parentheses in your calculator. Your calculator may know what you're doing, but it's more helpful for the calculator to know exactly what you're doing if I put fractions in parentheses, like such. So if I do 20 divided by 2/5, I end up with 50 as my x-intercept. So that means x is going to equal 50. Now, in case some of you don't have the ABC button, doesn't matter. I can do 20 divided by, and then parentheses, 2 divided by 5, end parenthesis, and I still would end up with 50 as my result. Okay, so I figured out my x-intercept. My next thing is to solve for my y-intercept, so we're going to cover up the x value. So I have 1/2 y equals 20. Again, I'm going to divide this 1/2 to both sides. So we're going to do 20 divided by 1/2. Again, please use parentheses for your fraction. So 20 divided by 1/2 is going to give me a y-intercept of 40. So my y-intercept equals 40. And then if you wanted to go through and write your coordinate value for this, it'd be 50, 0, and 0, 40. And that is how you go through and find your x and y intercepts based off of a standard form equation. So we'll talk about when we get to the back about how we can use this to graph, and this will be our first shortcut in graphing because this instantly provides me with 2 points that I can then go forward and graph. All right, so example 1 is just finding x and y intercepts as we just did. Now example 2 is going to ask us to go through and find our x and y intercepts for the situation that they give us, and then go through and interpret what they mean. So, for example 2a, we have the number of brake pads needed for a car is 4, and a manufacturing plant has 480 brake pads. Now, the number of brake pads remaining after brake pads have been installed on X cars is f of x equals 400 minus 4x. Now, you may be wondering, okay, how do I figure out my x and y intercepts for this? Okay, first thing that I want to do is I want to change this f of x equals 480 minus 4x. I want to change it into something we're more used to, which is using x and y. So I want to get rid of this f of x, and remember what we talked about before. F of x just is a fancy y, so I can write this as y equals 480 minus 4x, and that's going to look a little more normal. Now, what we have talked about so far today in finding our x and y intercepts, x and y have always been on the same side. It was something like 3x minus 2y equals 6, or 8x plus 7y equals 28, meaning this number needs to be by itself, and I need to move the x to the other side. So I'm going to add the 4x over, which is going to give me 4x plus y equals 480. Alright, so now that I have this in standard form, I have 4x plus y equals 480. I can now go through and find my x and y intercepts like I did up above. So again, to figure out our x-intercept, we're going to cover up the y's. So I now have 4x equals 480. So what I'm going to do is take 480 and divide it by 4, which gives me 120. So that means my x-intercept is at 120. And then to figure out my y-intercept, we're going to cover up x. So I have y equals 480. Now there's no number in front of y, so that means my y-intercept is just 480. Okay, so I now have my X and Y intercept. Now, if we want to go through and interpret, I'm first going to go through and graph these. Now, to graph these, remember, your X-intercept is where it crosses your X-axis. So my X-intercept is 120, so it crosses the X-axis at 120. And then my Y-intercept, my 480, is where it crosses the Y-axis. So that means my graph is going to cross Y at 480, which is going to be approximately right there. So I now have my 2 points, and in terms of graph, all I need is 2 points, and then I can just connect my 2 points. And my graph is going to look like that. So I have gone through and found my X and Y intercepts. I plotted my X-intercept at 120, plotted my Y-intercept at 480, connected my 2 points, and I drew my line. Now, what does my X and Y mean? Well, my X-intercept refers to the number of cars, 120, when there is 0 brake pads remaining. So my 120 refers to the number of cars it took to use up all the brake pads. So 120 is going to refer to how many cars it took to use up all of the brake pads. Now 480 is going to refer to how many brake pads I started out with. Okay, and I'm starting out with that because I've had 0 cars to put brake pads on. So that means 480 is how many brake pads I started out. So it's the starting amount of brake pads. And that is what my Y-intercept means. So X is always going to be the number of whatever your X-axis is telling you, how much of that it took to use up whatever your Y-axis is. And your Y-intercept is going to refer to the starting amount of whatever you're talking about. All right, so with that said, I do want to go through and practice another graph one and interpreting what it means. Just that way we have a little more practice with it. All right, so for part B on the back side, it's going to have us go through and do the same thing. It wants us to identify our X and Y intercepts and then graph them and then interpret what the X and Y intercepts mean. All right, first thing, we have a lake was stocked with 350 trout. Each year the population decreases by 14. The population of trout in the lake after X years is represented by the function, this f of x equals 350 minus 14x. Now, like I said with example 2a, we first need to go through and transform this into standard form. So the first step is to change my f of x to y. So it's going to be y equals 350 minus 14x. And then I'm going to add my 14x over to put it in standard form. So I have 14x plus y equals 350. Now that should be more familiar to what we have talked about and how we found the X and Y intercepts. So again, we're just going to use the cover-up method and use our calculator to figure out my X and Y intercepts. So if I cover up my y values, so I have 14x equals 350. So that means I'm going to do 350 divided by 14. And my x-intercept is going to be 25. And then if I cover up my x values to figure out my y-intercept, I have y equals 350. Again, there's no number in front of y, so that means my y-intercept is 350. So y equals 350. All right, so I've identified my x and y intercepts. So if we go through and plot my points, so my x-intercept is going to cross at 25. So on the x-axis, I'm going to plot my point at 25. Then my y-intercept is 350. So I'm going to plot my point on the y-axis at 350. So I have my 2 points. I can now draw my line like such. So I now have my line. So I accomplished finding my x and y intercept, graphing my line. Now I just need to go through and interpret what my x and y intercept mean. Now my x-intercept of 25, that refers to the number of years it took for the trout population to reach 0. So 25 refers to the number of years it took for the trout population to reach 0. Again, to figure out how you interpret it, so my x-intercept is going to be the value of what is on my x-axis, so time in years. So it's going to be how many years it takes for this to reach 0, or until nothing is left. Now my y-intercept is going to relate to my y-axis, and that's going to be the starting amount or starting point of whatever we're talking about. So 350 is the starting amount of trout in the lake. And that is interpreting my x and y intercept. So when you get to the ones that give you an f of x equals 350 minus 14x, or similar, take your f of x, change it to y, move the x over with the y, figure out your x and y intercepts, plot your points, and then interpret what both of them mean. And that is how you go through and do example 2. Now, part C is the same idea. It's just new problem, new situation, new equation. You would do the same thing we just did for parts A and B. Change this to y equals 10 minus 1/4 x. Move the 1/4 x over. Use the cover-up method to find x and y. Plot your points and interpret what they mean. Now, I will leave C for you to do. It is done in my completed notes, so you can always reference that if you want to see how that's done, or check to see if you are correct. If you need help with this problem, just let me know next time you see me, and I'll be more than happy to run through that one with you. All right, lastly, example 3 is going to ask us to use the intercepts to graph the line described in each situation. Now, if we look at A, for part A, we have 30y equals 18x plus 90. Now, we do not need to make a table. So before, I would have asked you to go through and make an xy table, plug in 2 or 3 values for x, and figure out what y equals. I'm going to show you a shortcut using the X and Y intercepts to graph these today. So the first thing is to find the X and Y intercepts, I need to have X and Y on the same side. Okay, I cannot have X by itself or Y by itself. X and Y have to be on the same side. So that means I'm going to move this 18x over, and because it's a positive 18x, I have to subtract it over. So that gives me negative 18x plus 30y equals 90. Now that I have X and Y on the same side, I can go through and find my X and Y intercepts by using the cover-up method, and then we'll go from there. So first of all, we're going to go through and cover up the Y value to figure out my X-intercept. So I now have negative 18x equals 90. So that means I'm going to do 90 divided by the number in front of x, which is negative 18. So if I do 90 divided by negative 18, I get x to be negative 5. So that is my X-intercept. And then to figure out my Y-intercept, we're going to cover up the x values. So I have 30y equals 90. So I'm going to do 90 divided by 30, the value in front of y. And I get y to equal 3. Okay, so I have x equals negative 5 and y equals 3. I'm going to use these 2 points to go through and construct my graph. Again, your x-intercept refers to where it crosses the x-axis, meaning my line is going to cross at negative 5 on the x-axis. So I go to negative 5, so 1, 2, 3, 4, 5. You're going to plot your first point, and then my y refers to where it crosses the y-axis. So it's going to cross at 3. So 1, 2, 3, and that's my next point. You do not plot a point at negative 5, comma 3. Okay, what this refers to is negative 5, comma 0 and 0, comma 3, as both these points indicate. So now that I have my 2 points, I can just go through and draw my graph. So instead of going through and creating an XY table, plugging in 3 points for X, solving for Y, okay, all I have to do for this is just get X and Y on the same side, use the cover-up method to figure out my X and Y intercepts, plot your points, and you're good to go. Now, you do the same thing for B, so you would need to get X over with Y. So I would have a negative 4x minus 3y equals negative 12. If you, excuse me, if you use the cover-up method, we would get x to equal 3 and y to equal 4, because negative 12 divided by negative 4 is 3, and negative 12 divided by negative 3 is 4. So I have x equals 3, y equals 4. So I plot a point at 3 on the x-axis, plot a point at 4 on the y-axis, and then I have my line, like such. And that is how we go through and graph our linear equation using the X and Y intercepts. So that is going to be our first shortcut, and we'll talk about that more when we get to Module 6. But that is it for Section 2 or 5.2 on using intercepts, specifically your X and Y intercept. So we talked about how to find your X and Y intercept using either plugging in zeros or the cover-up method. Then we've also talked about how to take an equation, find the X and Y intercepts, graph it, and interpret what they mean. So that is it for today's lesson. thank you guys for listening. By all means, and I highly suggest you use my completed notes as you go through the homework. Use it as a reference or come back to this video. If you have any questions or need any help, just let me know next time you see me or shoot me an email. But otherwise, that is it for today. Thank you for listening and have a great day. All right, bye.